Okay, guys, good morning. Starting the stream. Started it a bit later. Couldn't fall asleep last night, basically. Too much energy. Let me share the streaming link to Discord. Let's kick it off. There was apparently a very cool Arabic large language model paper that came in collaboration with Cerebras. So we can check that one out. Let me just share this. This stream. Okay, guys. Let's just see what's going on. Let me open up the live chat. Okay, I see people are joining. Guys, let's continue where we stopped last night. I'm kind of keeping this here at day 5, but it's day 7 really. And we're still dealing with data. Hello, Lalith. Welcome, man. Nice to see you here. Refactor my changes and push them out. Create readme detailing. Okay, so I really want to take some time to make the process reproducible. I'll create a readme with instructions of how you can run this and get the same structure locally yourself, and then people can start analyzing data. So that's the moment where we can delegate and ask some people from the community to help around their native languages and make sure we didn't make any mistakes. Also, some types of data analysis that people can do would be appreciated for their respective data sets. Whatever you think might make sense. I'm going to keep it open-ended for now. And then there's this paper that came out, Arabic LLM. We're going to check it out potentially even in this stream. But there is a ton of things. So let's start with FairSec. Again, let's wrap up that README. And then I have to do the same for Stopes. So it might be a bit more coding technical, not that exciting as just seeing new things, but we have to wrap this up. So Stopes and FairSec, I need to push the changes, and then okay. Let's start, guys. Let us start. Close this. Okay, where were we? So what I've done last night is I went ahead and re-downloaded all of our primary data. And so this is how the situation will look like when you just run the download parallel corpora. So let me open up the README. This is the official README from the NLLB repo. And here I'm going to start preparing a step-by-step tutorial of how to prepare this data. Okay. And then, okay, so they have some steps, but I want to add certain instructions that are specific to what we'll be doing. So let's add instructions. First, run the download parallel corpora. And download NLLB seed. That's the first step. And then we need to tell them which functions to run to get the structure into this regular pattern that we want. So you can ignore this for now. Let me see. I didn't download these datasets for now because I had some issues with them. We can handle that a bit later. Let me just re-download the NLLB seed. So let me just open this as like this, and then let me open the NLLB seed. We can download it with the following command. Let me just, by the way, can I open up a terminal directly in here in Ubuntu? That would be fun and useful. So just want to download this NLBC data. Let's navigate to datasets 2 and let's run this. Okay. It downloaded it here. Let's unzip it. Let's quickly unzip this one. Extract here and then delete. Okay, that's roughly it. Okay, second step, run the modify datasets script. And then step 3 is and prepare data, see the rest of the README. This is kind of steps before the actual steps here. So keeping it simple for now should be enough. Okay. Let's see whether anything else is worth mentioning here. Nope, nope, nope. Download, download. And there is the analyze script, which you can use if you want. If you want to analyze number of lines of bytext for each of the languages in the primary dataset, check out the analyze data script. Okay. Oh, hi Malvi, welcome. Didn't see your message, sorry, I was focused on writing down this README. And now I want to rerun this function on this newly downloaded set of datasets. So this is the raw form. This is how what we end up with once we run the download scripts. Let's try and rerun this. So first we have to shoehorn datasets into regular structure, not the nicest name, and then we want to map to BCP47. Map all language codes to BCP47. Let's quickly go through what I've done here. So we'll first have to change the datasets root. Let me put this. This should be part of the arguments here. Okay. Let's just copy paste this part into our script. Let's import argparse. Import argparse. And then, so script to okay. So datasets root is here. Let me create a new config. I'm gonna call it modify structure. It looks like this. What's the second argument? The second argument will just be hard-coded, so we don't need it. We don't need this, we just need the root. And it should be set to datasets root. Okay. Looking good. I'm gonna add this one here and then just pass in the arguments. And then here, oops. Exactly. Okay. So far so good. Let me specify that config here. And let's quickly go through what we are doing here. So this will prepare all of our primary data. So we go through all of the datasets underneath the root. We create the particular dataset path. So it's going to be first AAU. We grab the content of that directory, and then we have a couple of special cases. If the dataset name is indic NLP, because this is an n-way parallel dataset, so we had to handle it a bit different. The second edge case is NLB seed, and then if it's neither of those, then we do the following. We go through the content of the dataset, and it will either be like this, where we have different directories with language codes, which represents the direction. So this is AMH language to English, whatever this is Amharic or something. And then this one, as you can see, this one is flat. This one has files. So that means his directories will not be set to true, it will be set to false, and will be basically entering here. Okay. This one, again, same structure. This one flat, this one is flat, this one is flat, this one is flat as well, this one is in the good format, this one is in a special format, this is in a flat format, good format, flat format with a particular train TSV which we need to ignore, flat format, well actually not, because it has the direction here, but it's, as you can see, combination of BCP47 code, which means language code plus script, and just language code. And then flat, special structure, because it has BCP47, flat. Okay, flat and flat. Okay, so we maybe, what might be good is maybe we can even run this one even before or no, we first want to run, I think we first want to run the structure. Let's just do it the same way we did it the last time. So we go through the contents of the directory. We ask if all of them are directories. In that case, let me just delete this. So in that case, we pass, otherwise, okay. So if it doesn't have directories, if it doesn't have directories, then we enter here. And let's see what we do. So for all of those flat, again, let me just make sure this makes sense. It's either this, it's either all files or it's all directories, all files. Okay, this one is messed up, this one, but it's a special case, so we don't care. It's either all files or it's all directories. So that's the assumption we can make. Okay. So for this particular data set, we grab all of the files which are supported. And this is handled by this particular function here. And we just grab the file. So this is the new content. This is the filtered content. If the length is 0, we can print found no supported files there. Otherwise, we assert that we have exactly 2 files. And in that case, we grab the first file, we grab the suffix, and we grab the second file, and we grab the suffix. Sure, Molly. So TLDR, once we download the data, we want to bring it into the uniform format. So as you can see here, this data set has files beneath it, whereas some other ones, like maybe this one, first has the language direction directory, like English to Kurdish, and then underneath it, it has files. So we want to bring all of the data sets into a particular structure. First, we want to have dataset name. Then we want to have language directions. But instead of having these 3-letter codes, we want to have the so-called BCP47 code, where you have the 3-letter code and then the script, which has 4 letters. And then underneath it, we want to have 2 files and only 2 files, again, with the suffix being in the BCP47. So that's what we're trying to do with this script. Once we do that, I'm going to create the README so that you can rerun this locally and get that same structure, and then you can start playing. So you can do a couple of things. One thing you can do is you can contribute for your native language. You can go and verify, go through all of these data sets, find your particular language and see whether translations make sense. If you notice any issue, some bad translations or something, you can submit that feedback to the channel. That's one thing. Second thing is you can play with data. Just do some analysis, whatever you think might be useful. Visualize stuff, number of sentences, number of tokens, whatever you want, really. Embed it, do whatever you want. So that's kind of how you can help at this stage, because we are still at the stage of making sure data sets the data is being prepared, and then we can kick off the model run. So we are still just thinking about data at this point. Hopefully that answers your question. Let me know if you need any more help. So no worries. So if the length is 2, that means we are dealing with ISO 6391, and then we converted code to the actual ISO 6393 code. We create the directories. We grab the file name. We construct the new file names. Maybe we can do everything in the same go, although that might be complicated. Let me just think. It might take a while for me to just figure out what's the nicest way to handle this. And it might not be the most exciting content, but hopefully you'll learn something. And this is, by the way, most of machine learning is just dealing with data, dealing with these things. So let's see, here we find the prefix of the file name, and then we append the new language code. Will this make sense? Will this make sense? So if we have files, okay, I think this makes sense. Let me just think. Dataset name, dataset path, dataset content. And then if the content is all directories, if we don't have directories, then we go here, we filter, we do some asserts, we grab the suffixes, we map them to the 3-letter code. Why not do it immediately? So we can do everything in the same go, right? We can just merge these two functions. I want to immediately deal with BCP47 instead of dealing with 6393. So I think we can do that. Let's just see what's the best way. For now, let's just understand this function and whether it makes sense. So we create a new directory under the dataset path, which is, okay. So we add the language directions for both directions, language code 1 to 2 and 2 to 1. And then we rename the files. Okay. And then copy and delete. We'll just copy the file into that directory and then remove the original file. Okay, I understand what's going on here. Now I want to combine that with the first function. This guy again goes through the datasets root, grabs the dataset path, and then goes through the subdirectories of that dataset and says the following thing. Here is the element. If it's not a directory, we skip, because we expect already the right structure from the below function. Otherwise, we grab the directions, source and target language codes, and then we map them first to 6393, and then okay, let's do this. Element path. If it's not a directory, we skip. We don't want to do that. We want to do something like this. Directly in here. Here are the language codes. If you're equal to 2, then we've already done that here. So we can already guarantee that's here happening. Okay. I might introduce some errors if I start merging them. I'm gonna just for now give up and run them even though it's not optimal. So let's see how am I handling NLLB seed. We go for this particular one. Potentially remove the script name from directory name. No, let's not do that now. Let's just go through the content. Grab the codes. Create a new, what's this? Okay, we just create the path to that direction. We list the files and then we go through the files. We grab the language code from the file and we construct a new file name by doing this. And then we rename the file to that new name. So that's everything we're doing. Because NLLB seed has something like this. So why not? So let's make our lives easier because we ultimately want to be in the BCP code. We don't want to do this. We just want to add the suffix. We just want to do this. We want to be file and ignore the language code. Does that make sense? So because the file names here are already BCP47, we just want to rename it so that we have the suffix to be the same thing. And that's it. So now after this, after we do this, NLLB seed is already ready. We have nothing else to do. And additionally, we are not using this temporary directory for anything, so we can just delete all this. So cleaning it a bit to have the BCP47 language code as extension to prevent adding multiple suffixes. Okay. If dot already exists in the file name, we continue. Okay, so this is perfect. NLLB seed is already in the good shape after we run this single function. For the indic NLLP, the situation is a bit different. Let's see. So it has a very special structure. indic NLLB has a very special structure. Let me open it up. Here it is. It has indic NLLB, then final repo. And then underneath it, we only care about train. Okay. So we create the non-train. We don't need to create this. We don't need to do this as well. We can just add those here. Let's make directories here. So let's make this one. And let's make the datasets root. Make directories dataset root. I can probably do that for Gurajati. Hi Mo, is what language is Gurajati? Where is that spoken in Malaysia, right? Or where is it the official language? So pardon my ignorance. But in a couple of weeks, believe me, I'll know every single language that with this rhythm. Okay, so we create this special path for indic, and then we do the following. We grab the readme and we move it to the non-train. Okay, instead of doing that, we actually need to create a target. Target directory is going to be ospath join. This followed by dataset name, and dataset name is no, sorry. This is not right. Target directory should be in here. So we do ospath join non-train and dataset name, exactly. And so we move this to target directory readme. Okay, same thing for the dev dataset, same thing for the test dataset. So now we are left with just train. So once we have train, we create a new path. Here's the train path. We grab the directories. We grab the set of directories under train, because train also has some two files here that we want to ignore. Indo-Aryan ethno-linguistic group who resides in or can trace their ancestry or heritage to a region of Indian subcontinent primarily centered in the present-day western Indian state of Gujarat. They primarily speak Gujarati and Indo-Aryan language from Wiki. Yeah, Malvi, I think Malvi speaks the language. That's the whole point. She speaks the language. She can tell us more as well. Okay, so we go through the train path. If it's a directory, then we move it. So the nice thing about indic NLLB is that we can just grab this directory and move it to the dataset root, because it's already ready, ignoring the fact that it's 2-letter codes instead of BCP47, but we can handle that later. If it's not, then we move it to target directory. Target directory under train. Okay, and then we remove the whole thing. We remove the dataset path. We remove the indic NLLB. And then finally, we go through directories. we go through the okay, we split, we copy to that one. I don't think we need to do this. All of this can be handled by the BCP47 function above. So what we do here is we map, we want to rename this to 3-letter codes, and then we want to rename the directories to 3-letter codes. Let me see whether this is redundant, because this function here will be doing the same thing. Rename for files and for directories. Yes, we definitely don't need to do this. Let's delete this, and we are done. This is the indic NLP. Guys, I think we're ready. So this function is now in such a situation that we'll end up with the right structure, minus the fact that some codes will not be BCP47. That's the output of this function. And then we go here, and we make sure that everything is in BCP47. We could potentially merge these, but as I said, let's for now keep it like this. Okay. Let's see the arguments, and let's see what this function does. Does it make sense? We go through the datasets roots, we grab the directory, and then we go through its language directions, okay? If it's not the directory, we skip. Otherwise, we grab the source and target language. We map it to 3-letter codes. If it's in the unsupported languages, we note that, and then we push it to, we just make directory in this non-trained datasets path, and we move this there. Okay, makes sense. And then we go here. If it's in the ambiguous codes, if any of them is in the ambiguous code, we mark that with a flag. And then if it's not, if the code is not in keys here, then it has to already be in the BCP47 code. Otherwise, we map to BCP47, and same for the target. So after this, we have the source and target in BCP47. We've filtered out the unsupported languages, and we've marked the ambiguous languages. We rename the directory, and then we go through the files inside of the directory. We grab the suffix. Again, we map it to 3-letter code first, and then we map it to the BCP47. We grab the prefix and we rename the file. Okay, guys, this should work. So this should now work. Let's see if there are any issues, and then we can basically just wrap up the README and continue. there's a couple of notes and things I had to do. Let me see where we're using all of these mappings. Remove script Latin from language direction name. Okay, let's see, what do we say about this one? What's so special about this Mineng NLP? No, we don't want to do that. That's fine. Notes manual renamed. Okay. And I had to manually rename some stuff. Okay, there is a ton of gotchas, but I hope this will be enough. If not, we'll have to rerun everything again. Let's start, guys. I have the right config set up here. Okay, of course, every time VS Code is for some reason being smart and adding this prefix. Okay. Let's go into this first function. Let's expand all of this. Let's expand all of this. Let's see what happens with our dataset. So I'm going to delete the content of this guy. So that we start from a blank slate, and let's go. So we go through datasets names. First one is this one. We say we are processing because it's not special case and because it doesn't have directories. As you can tell here, we grab its contents. We assert that we have exactly two. We grab the suffixes, as you can see, English and XHO. We map those. No, actually, we just create two directories, as you can see here, and then we basically just paste the files there. And we're now in the right structure, you can see here. So language direction and both files. Let's continue. Second data set is CMU Haitian. I think we can safely just hit F5. And CMU Haitian is in the right structure again. Let's continue. Now we're dealing with Bionet. This one is already in the right structure. So let's just make sure we skip. We don't do anything here. We don't do anything. Okay, that's it. And then Gyosa. Gyosa, we should safely be able to hit F5. And we end up with, again, directory with the language direction and actual files. Let's see, we're dealing now with Lingala songs. Lingala songs, again, we can hit F5. Lingala songs handled correctly. Now we're dealing with Akuapem. Again, we can hit F5 and we dealt with that one correctly. Now we're dealing with Umsuka. and we can just hit F5. Again, it should be handled correctly. Msuka is handled correctly. We're dealing with NLLB seed. So that one is a special case. So let's go through it. So let's see what happens here. Why am I ignoring source and target? Okay, so for this guy, directories are already in the nice format. So that means we can ignore this. We grab the files and we just create a new file name. And that's it. So fairly simple for NLLB seed. We just make sure we add the suffix here. So we can hit F5. And let's verify that NLLB seed is processed correctly. As you can see here, all of these files now have the right suffix. Looking good. Okay. I'm just going to comment out this part. Kenya SMT. We can just hit F5. Kenya SMT has been processed correctly. Now we are dealing with Indic NLP. Again, this is a special case. So let's see what we do. We are going to now be... I'm curious whether this will work, because target directory doesn't yet have... Yeah, that's what I thought. So we have to first create the target directory before we can push stuff there. That was my mistake. Let's just rerun. Let's just rerun. F5. Okay, we are back into Indic. So let's just make sure that we'll be pushing this here. Okay, so now we have Indic NLP and we push this there. And here is the README. And then we push this there. Here is the dev as well. And here is the test. So we just move that Indic NLP. The things we're not using, I just push them out into this different directory. And then we grab the names, which we will not be using, so we don't care. So we just go, and if it's a directory, if it's not, let's just move it. Train path. Again, this does not exist. Okay, that's what I thought. This does not exist, so I have to train path. I have to do os make directory, and I can delete this safely. Let's continue again. Hit F5. We are here. We can just safely ignore all of this because it can't do it because we've already done it. Train path. Okay. Did I add? Okay, I forgot to add exists. Okay, true. That's the iterative nature of our job. Hit F5. And then now we should be able to wait. I made a mistake again. This is not the target directory. Lucky third time. Okay, looking good. So move there. Why are you failing again? My God. Oh my God. Wait. Because I'm really stupid. I should just be using train here. So just move to train to target there. Otherwise, we move train path element to dataset root element. Okay. Let's go. Okay, so we move this to here, hopefully. Exactly. Again, now we keep on moving these guys to the root of datasets 2. Here it is, Wiki matrix added. Yet another one added, etc. etc. Hi Mirko, welcome. Okay, we can hit F5. We are done. Continue. Didn't we already delete indic NLP? We should have deleted it. Okay, here we are. Let's see what's the next one. For an MT. This one, we should just be able to skip it safely. And then the next one is this one, Mubirisano. Let's see. We can skip it as well. And then French Iwi. French Iwi. This one should be handled correctly. Let's see, French Iwi. Looking good. Let's hit F5 for FFR. This one should be handled correctly as well. Looking good. Now we're dealing with Ninor's memories. This one should be handled as well. Now we're handling AAU. I think this is one of the last ones. We can just skip it, nothing happens there. And then French Fongbi. French Fongbi. Let's handle that one. French Fongbi is handled. Next up, Taiko. Taiko, we should just skip it. I don't think we have to do anything for Taiko. Taiko is already in the right form. Minang NLP. This one will be handled, but let's see what will happen exactly. Hitting F5 because it's heterogeneous in the sense of different codes. Minang NLP. Okay, we have actually nothing happened because it only has a directory. And then till we should skip it as well. And finally Menio 20K. This one should be handled. let's see what happens exactly. So menu 20K is now, as you can see, handled correctly. We grab these two files, we put them into one language direction, and the second two files here. Good morning, SQ. Welcome. Mukibi should be handled. Huh, interesting. Oh. Okay, so we handled it correctly, and then we entered the map all languages to BCP47. Okay. So making progress. Let's see where we hit an error here. Where do we hit an error? This is for Bianet dataset. And Kurdish is not handled well. Because why? Why don't we have Kurdish in the... I thought we added that one to code mappings here. Let's see. Kurdish. Nope, it's not added. Even though, if we take a look at notes on the languages, Kurdish should be mapped to Northern Kurdish. Let's see. Let's see, what does the paper say again? I forgot the detail. Do we support both Kurdish languages, or actually there are three separate languages. There is a Northern, there is a Central, and there is a Southern Kurdish. Central Kurdish. Okay, we support Northern and Central, but not the Southern. Central, Northern. The Central has Arabic script. Let's just double check what's happening in the Bianet dataset. Guys, after this, you'll be able to run this locally. I'm just gonna push the changes, and you can run this locally, and everything will just work. Let's go to Bianet. Let's open up the Kurdish. It's Latin, so that means this one is Northern Kurdish. Is that what my notes said as well? Let's see. So Kurdish, Northern Kurdish. Let's add that mapping here. Kurdish. If there is an ambiguity, we're going to map it to this one as well. Let me just add a note. Okay. Manually adding after analyzing Bianet dataset and seeing Latin script. Okay. Let's go back and let us rerun. We are done here. Processing, processing, processing. Skipping, skipping, skipping. Found no supported files in this one. Fair enough. Let's see why we're skipping English your we should have added a bit more information to okay, this is actually from this function below, from retrieve supported files. Skipping the file. Because what's this your, let's go to the mappings. Here, what's your? Your is your Latin. Okay, let's see what happens. Let's go back to our script. Hit F5. Again, we are hitting some issue with Tico. Apparently, okay, I knew this one is still left to be handled. What do we want to do with this one? I think I have to manually rename for this one. So we can say if it's TIRET, we can just map it to ATHI. Okay, let's do it like this. Let's go to the mapping. And let's just add sounds like the best option with a comment seems best. I'm not sure what you're referring to. This should now work. Let's rerun. Okay, guys, that's it. That's it. Everything is now working. Hopefully I didn't introduce any errors whatsoever, but this is now a process data set. Let's quickly go and verify it makes sense. So here's the first one. You can see we have BCP47 codes here, as expected. Same here. Same here. Same everywhere apparently. So that was our goal. Have a homogeneous structure so that all of the data sets conform to that particular structure. Now it's very easy to just go and handle this, because everything is just in the same structure, and now we just have byte text here, and we can use that to filter it out and then prepare it and then run the training. So I think this logic here was very, very important. I'd love to have some eyes on this. Maybe somebody can go through this and see whether we have any issues. Let us now try and run the filtering pipeline, because previously I had to rename. After I ran this script, I had to do some more renaming. And that means we had some errors. Let me just edit the README. Like this. this. And that should be it. Let's now run the filtering script. Go to Stopes. Apparently there were some jobs that failed here. We'll see what exactly happened. But it looks like the filtering pipeline worked for the better part. Okay. So let's run again. Let's run filtering. Let me just change the output directory to be here. Filter configs. Like this. Let us run filtering pipeline. First, we need to rerun populate data config. We change this to datasets 2 because that's our root now. And we dump everything to filter configs, that's fine. And we can rerun this. Let's see whether this fails. If this fails, that means we had some issues in the previous step. Okay, I didn't set the right config, I guess. No args config. Now we can run this. Okay, looking good. Nothing failed, and we dumped a new primary. So train primary. Here it is. And now let's run the compute length vectors. Let's see where that one's gonna fail. Flores path. This one should just work. Okay. And then finally extract directions and corpora. Let me see whether we have to do anything else here. Unfiltered corpora. We grab the primary YAML and we dump directions, and then we save that. Okay, we can just rerun this. Okay, looking good. And now we can run the filtering pipeline. So if this fails, if there are some issues, we'll soon know. Are there any particular, we have to change the filtering config, and here we pick another output so that we don't override the previous one. And let's kick it off. Let's kick off this run. Run. Looking good. All directions are here. We have in total, how many directions do we have? Let's just do the length of this variable because it's a list. 277. That sounds, that's a bit less than what I expected. Maybe we have some hidden errors. Hey Navjot, welcome. Corpora, we have 37. That looks good. Let me hit F5. And let's see whether we get processes failing immediately or whatnot. Looking good, folks. So far, this looks, I think I don't have any errors that I previously encountered. So we can go back to FairSec and we can remove all of these comments here. I had to manually rename some stuff, not anymore, because now we fixed the code. We added this to our mapping. Let me put this below. Let me put this function here because that's how we call it in the main script. We first call the shoehorn, then we call the mapping to BCP47. Looking good. Let me put some to-dos here. Someone to confirm that empty English to Odia indeed has Odia, not the other language. I'm gonna put this here. If anybody speaks one of these languages, let me know. That's gonna be super helpful. So we need help with Northern Uzbek, Oromo, Pashto, Ethiopian, Southwestern Dinka, or Odia. By the way, some of these are macro languages, but still. Okay, modify the structure. Let's see. I can remove all of these comments here if in case I have explanation here. Let me put this, split this to right and reopen the modify script. Okay, so what did I write here? I also manually had to map ORI to ORI because ORI is a macro language. Consists out of 2 languages. And NLLB only supports Odia, which is written in Odia script. I think I just included it here. Yes. You can delete this. Okay. I'll leave a couple of notes here. And we still need to see whether we want to add both directions for each language pair. So if we have 2 files, do we want to always create 2 directories with 2 different language directions? Because given a pairing, you can pass that as the source first and target, or target first and then source. So you can create 2, you can get 2x the data if you want. But is that a good idea? I'm not sure. So let's leave a to-do here. Okay. This file now looks reasonable. Let's see what's the output of our last one. I'm gonna remove this from here and I'm gonna put it into individual places. Because only when we get here will we actually process the data. Okay, looking good. Let's see what we got here. Skipping, processing, unsupported language code. Okay. If I rerun the file, what will happen? Why are we hitting processing again? I know this is boring, guys, but I have to make sure that there are no mistakes here. Why are we hitting processing? Okay, because here, map language codes. Okay, here it is. Again, we're hitting some weird issues on the filtering side. I'm not sure what happens there. Maybe in some of the data sets we filter out all of the output lines, and because of that it's failing. Thanks, SQ. Let me just again move here inside of the map the languages to BCP47. Let's move this to only when we actually do the mapping. Are we actually doing the mappings? So we grab the source and target. Okay, so if the source and target are both in the BCP47 already, in that case, let's just skip this whole thing. If it's not the directory, we skip, otherwise we come here. Okay, let's add another condition. If this source is already BCP code, how can we figure that out? Let's see. BCP47. I think we can just create something like a new variable that will contain all of the BCP47 codes. Supported ISO codes. Let's go and do the following thing for the supported BCP47 codes. And we'll grab the values. Now the issue here is the values are lists. So what we want to do, how can we just extend all of these lists together without having to be explicit? So we can do something like this. BCP47 codes. We start with an empty list, then we iterate through all of the values, and then we just extend this, and then we just finally add it here. That's one implementation we can do. Let's make sure this makes sense. And now let's also assert that the length of this guy is exactly 202, because that's the expectation set from NLLB side. Let's go back here. Let's import this new variable. And let's add it here. So if source in this and target in this, we just continue because we already have the right codes. No, but what if the files? It can happen that the directories are in the right code. Maybe the files are still not. So that's dangerous to do. We can do this, actually. This is my mistake. We can do this. We can do this here for files. We can do that here. Okay, let's now rerun it and see the output. Okay, but got 214. Oh, because those are not unique, right? Let's just make them unique. Now it should work. Let's run. Okay, here we are. Mapping. skipping the train TSV, looking good. Skipping TSV. Why is it skipping your lectin? Why is it skipping this pair in particular? Out of all possible pairs, why that one? Let's see. Okay, let's go to menu. Let me open up menu. Okay, it's skipping because it has train TSV here. Okay, makes sense. It's skipping because it's not a file. It finds this file and it triggers. So what happens is it finds that file and that leads it to this branch of the code. It leads it here. And then this function here basically just says these are not all files, right? So we can just do if it's a file, then we do this. And then if we run this, now we have just skipping file train TSV and found no supported files in menu. Fair enough. That should be it. I'm not 100% confident that there are 0 errors because of some of these ambiguities in different languages that I don't speak, so I can't be 100% sure. But this is the best I can do for now. Okay. I'm pushing this out, guys, and you can try it on your side. We'll certainly get back again to this part of the code base because we'll be iterating, adding mine data later as well, etc., etc. But for now, I think we're done here. Let's add these files. Let me just navigate back to the root. Copy this one. Copy this one. Copy this one. Copy the analyze one. Why did analyze change? For some reason, sometimes it's changing the imports. Yes, as you can see here, it's changing the imports without me telling it to do that, and that's screwing up with the logic. Okay, ISO mappings. These ones are just YAML files. we can ignore all of them. And then data zip. Okay. Modify the structure. Looking good. Why are you complaining about this one? Git add. Do we have anything else? YAML, nothing there. Okay. And finally, this one. That's it. Okay, looking good. Nice. Thanks, SQ. Okay, guys. Let's see where next. What are our next steps? Okay, so next steps are, if somebody can run this, that would be amazing. So if someone can, let me just open up the repo here. How much space does it need? Around 35 gigabytes roughly for all of the data sets. But you can, if you wish, one of those data sets takes the most space, like around 30, so you can comment out that particular line and then you can run it. Let me just find, so examples, NLLB, here it is, and then data, and then this particular README. If someone can set up the repo and follow along the README, so as to set up the datasets locally and test all looks good, that would be amazing. Okay. Let me just remove the embeds. Okay, looking good. Now let's go to Stopes. Let's do the same thing for Stopes, and then I think Stopes is mostly YAML files though. And then we can see what happened with filtering, and then we can go through the paper, and finally we can skip to the data processing pipeline. So let me quickly go through Stopes. Let's not waste any more time. Let's go through Stopes. Let me hit F5. Again, this is done, but there were some errors of the sort error stream produced has not produced any output. I wonder how many of them had that same faith. So if we go here, filter out, train primary. So here are all of our language directions, and underneath it, some of these guys don't have anything, which sucks. That's weird. Okay, that's not good. Something is not okay here. Some of these have the files, some of them don't, most of them don't, especially the latter ones. Maybe this is just too many processes errors. So as you can see here, most of these directions have the output, whereas the latter one do not. So probably just processing, lack of compute, or I'm trying to schedule too many processes and it's failing. So we can somehow handle that by splitting the job into multiple runs or something. I think that's literally the case. So if we open this, okay, this is obviously encoded, so we can't see it before we unzip. Let me see what have I done with Stopes. Stopes, change directory, go to Stopes. Let's see the status here. YAML, config spy, data, extract directions, temp. Okay, there's a couple of things that we will want to check in here. I'll be in the office later. My internet at home is terrible, but I'll run in a couple of hours. Entire. Awesome. Thanks, SQ. That would be amazing. Just report back in the channel there, and let's see whether you had any issues. If you hit any issues, please just take a snapshot or log what you've encountered. Okay, let's now go and see which files we need to take care of. Config spy under filtering, pipelines filtering, config spy. Okay, what do we have here as a change? I think I just changed one of the paths. Yes. So I change this to, why not just grab the location of this file. Yeah. What's the best thing to do here? Because somebody will have to download this data set if you want to run toxicity filtering. Can we make it agnostic? Can we make it such that anybody can just run this? But then there is an expectation that we know where they'll download this data set. So either way, that's going to be problematic, right? Unless we say something in a README for filtering. If we make some assumption where they're going to download this data set. This should be in a config. This should be in a config, but I'm not sure what's the best thing to do right now. By the way, I haven't been using toxicity lists yet. We can use them soon. But for now, we can ignore this. But let me see what we can do this here. Okay, I have an idea. I'm just gonna say the following thing. Let's see where this one is mentioned. Only there. Let's go to README. And let's add a note. Okay, let's just specify Flores toxicity. Let's specify this guy. You can just run this. From here, you can just run this line. And then there is the unzip function. Just a second, let me collapse all of this. Let me collapse this. I do have the unzip script. But that one is in FairSec. I'm just thinking, how can we make this a bit less annoying for people? So you can run this code to download the script, and then you can run from FairSec. You can run. Here is the script. Unzip toxicity lists. Copy path. Okay. And that particular list expects, that particular script expects that you set up the root here. Okay, so we'll be keeping the data in FairSec because that's where the download scripts are. So let's tell them that. Let's tell them to download this one to FairSec. Why is this? Okay. Let's find the toxicity filter, toxicity filter. Actually, toxicity config here. Okay. Now let's make this a cohesive flow. To make things a bit easier, please download the above file to your PureSec root, because we are downloading and doing initial datasets preparations there. You can just run this from PureSec project root directory, then run the following bash script. Again, it's in the PureSec repo. It assumes downloaded the toxicity lists to PureSec's root. I'm being a bit repetitive, but better to be repetitive than for people to be confused. Finally, you'll have to modify the path to your word lists inside the path to your word list inside filter config. At the moment, it's hard coded. Okay. Fair enough. Now if we go here, either way it will be broken, so I'm gonna just keep it as it is. Because they have to set it up first. Okay, let's go further. So that's the configs. I have to, so we can add, which branch am I on? Let me just see. I'm on the main branch. Do we want to do this on the main branch, or let's just set NLLB? Let's set the same branch as in PureSec. So in PureSec we have NLLB replication branch. So here again, let's set, and we'll make that the default branch as well. So we are now on the NLLB replication branch. Let's add all these files that are already ready. So README is ready, configs is ready, filter.py. Let's see that guy. So memory, again, this is unfortunately hard coded. We'll have to, because I'm assuming people won't have this much memory. Yeah, we'll have to figure this out. I have 16 processes on my system. I mean, cores. Oops. There is a couple of changes here. Okay, this is good enough for now. Then there is the length pipe. This one had some bugs, so I had to fix it. I just added a to-do there. We'll see what to do about it a bit later. Then we have compute length factors. So again, this was a bug because they used the three-letter code, and in reality they have to use the BCP47. So that was a bug. And then I've hard-coded this here, which is not good. I'm gonna instead create a long JSON for compute length factors. So let me add this to be required. Let me create a long JSON for populate data config. Let's add arguments. And we need to add what? We need to add floors path. Which is going to be, for me, this path. And then we can now remove this. And same thing here for data config directory. Let's set this up to be this. And we are done. We can now remove default, set this to true, and now I doubt we have any modifications there. Okay, this is the original code. Let's just try and rerun this, see whether we have any issues with the new config. So let's run. Okay, looking good. We have Flores path and data config. Awesome. This works. So we can add the compute length factors. Populate data config. Let's see the changes I've done there. Populate data config. Let's see the changes I've done. Okay, I significantly modified this function. We don't need this to do anymore. Again, I've just set up, I've hard-coded things directly here to make it a bit easier. let me first go through extract directions and corpora. So this guy, this script will create 2 YAML configs. Let's just make this a relative path as opposed to being hard-coded to my particular environment. Prepares 2 additional YAML configs using source of information. The purpose is to make example YAML config more readable and easier to maintain. Instead of dumping directions and corpora information directly into example config, we instead link paths to these YAML files. Okay, and now how does one, using pathlib, how do we create a relative path? So we are currently here under scripts, and we want to under filtering. Under filtering scripts, we exit there, and then we go filter configs, and then okay. Trying to prompt Copilot, but it's not working. Yes, exactly. So we want to grab the parent, and then we want to go where? We want to go here. Will this work? Let's make sure this works. What is currently being run? Compute length vectors. Where are we running that one? Okay. Let's go back here. No arguments. So the path looks to be correct. Filtering. parent. Wait. Okay, parent. We have to go like this. Will that work? Filtering. Just show me the line. Oh my god. Super annoying. Let me just print it here. Okay, under filtering. Filter configs. Unfilter corpora. Okay. Looking good. I know it's not perfect, it's a lot of assumptions, but guys, for now, I want to get this working end to end, and then we're gonna fix the rough edges. Let's try and run this. Let's delete train primary. Actually, let's delete these two files. And let's run our extract file. And it looks it worked. So it worked. So now we can just make a note, like let's just mention somewhere in the README that you'll subsequently link inside of the example YAML script. See the rest. See below. Okay. Made a quick mention there. Now let's add this new file. Let's see what this filters temporary file is. Nothing. Let's delete it. Anything else? This is just data. Filtering directions txt. What is this? Okay, we can remove this as well. Move to trash. Out data 3. Why do I have so much? Okay, because I was playing with prepared data. That's all fine. That's all fine. So the last thing is populate data config. Let's just sort out this one. Let's go to scripts, populate data config. And let's create a new config. No, this one was actually, let me copy paste it. But this one was compute length vectors. Okay, and this is popular data config actually. So for this to run this, we need to pass in primary train paths. Primary train paths. In particular, this path. Okay. And then we need to do what? We need to set this to required. Remove this path. Exactly. I'll leave these two as false because we are still at the stage where we don't need to pass those two. Data config directory. Let's pass in this one. Okay, this is the same argument, so we can just set this to, again, true, and remove this. And finally, data type train primary, I'm going to leave this as it is. That's good. Let's try and run this with populate data config. Let's run this. Parse. Looking good. Primary train paths. We have the path there. Data type, we have it. And data config directory is also good. Okay, that's it. Let's add the file. I think we added everything. Okay, we have to add this README as well. And everything else is just data. Okay, commit. So what have we done? We made it a bit easier to run the filtering jobs. Okay. Push origin, we have to first set the upstream branch. Oh. Okay, just a second. We actually don't have the repo yet. So we have the open NLLB. Oops. GitHub. Let's fork this one. Open NLLB. Oops. open NLLB effort. Copy the main branch only. That's what we need to do. Looking good. We are forking. And now I can actually set the change the origin. So currently our origin is git remote verbose. So this is the origin. We want to set that to the new repo. Origin is going to be this one. Okay. Now push to origin, and now set this. Okay. And looking good. Remote rejected because why? What? I don't understand. Why is it complaining? Maybe because of my GitHub token. Let me see how I made this one. This one should work. Why is it not working? Push setup stream. Failed to push some references there. I don't understand. What's going on? Remote rejected. Refusing to allow a personal access token to create or update flow. Okay. Let's see now. Nice. So we just, my token that I was using to log in didn't have the required scope. So I just had to create a new token quickly and that's it. Okay guys, now let's go to settings. And let's change default branch from main to NLLB application. Let's update this. And this is now the main branch. Okay, let me Okay. Just a second. Oh snap. Lost access to my token. Okay, I'll handle that a bit later. Okay, let me actually just generate a new token. Open NLLB effort, public and workflow. Just a second. So new token, open NLLB, no expiration, public repo, workflow. Generate the token, and let's now keep on using that token from now on. That's it. Okay. Finally, let me just put this one somewhere here. Let's remove the deep dream. Let's add the open stopes, save pins, and let's put that one all the way up there. Okay, looking good. That's it. Let's go back to Notion. Refactor and push. Let's see. What should we do next? Robustify filtering. We need to get the filtering to run, see what's the issue there. We can check out the Arabic paper, and then we can work on the data processing pipeline. Before jumping, I want to just see a bit of organizational stuff, and then we can see the filtering, and then later in the evening I think we can check out the paper. Something like this. This is long due, so I have to just take care a bit of the organizational stuff. Let's see what Chris proposed here. Separate project document either on the GitHub or GDocs. Fair enough. I think, should we keep this one on Google Docs, or I'm kind of using the README of the OpenNLB as that document. So I just, if you take a look at the README here, I made a OpenNLB effort brief description here. I'm gonna leave this one expanded because it's important for people to see it. And maybe we can have, let's add a role for this channel so that I can tag people when we have additional tasks. Okay. I privately use Notion as well. Polylingual uses Google Docs. Let me create a new role. See where we have anything similar. NLP study group. Nobody currently has that role. Why? There is a ton of these Patreon roles. Let me create. By the way, guys, feel free to support me on Patreon. Small plug. Open NLLB. Let's give it a very strong color. Permissions. No special permissions. I can just tag you. Let me see whether I can I manually add people? Yeah, I think I can give everyone the role myself. Everybody who has been engaging in this channel, I think we can just give them the roles so that we can tag people here. Okay, Brian, open NLLB. Raphael as well. Open NLB. Open NLLB role. Bilgehan as well. Open NLLB role. Emrit. Okay. Same here. I'm just gonna add everyone who interacted, and they can remove the roles if they don't want it. But I think most people want to contribute here. Okay, Chris. There's been a ton of people who started interacting recently. Okay. Everyone who interacted in this channel has been given a new OpenLB role that I'll be using to notify about relevant tasks. For start, check out the language champions document and add your name next to your native language that you want to own. Just make a proposal and I'll review and accept it. Even if other people already signed up for your native language, you can still add your name. The more people we have, the better. No worries, Vezdan. Let me just share the link. Okay, a good community task would be for you to the following. set up the open NLLB repo locally. First, follow the installation instructions for NLLB, and then follow along the README so as to set up the dataset locally and test all looks okay. Let me just edit this. If we open up this code, if we open up this link, what will happen? What's the landing page README here? Is there any mention of installation? Installation, okay. Oops. I think I made a actually issue. Let me quickly open up my LinkedIn. Posts. Okay. And then we go through the files for your native language and see whether there are any issues. Additionally, feel free to do whatever type of analysis you see fit, embedding the sentences, visualizing, counting the number of sentences / words for your native language, etc., etc. Okay. Relevant tasks. For start, check out the language champion document. For start, if you haven't already, please check out the language champions document and add your name next to your language that you want to own. I'll review and accept it, even if and then follow along the README so as to set up the datasets locally. Additionally, feel free to do whatever type of analysis you fit, embedding the sentences, visualizing, counting number of sentences, words, etc., etc. Okay, I think that's a good start. And then 3. advanced, step through the code I've written here. Go to examples, NLLB, data, modify structure. Okay, and then yeah, I think that's enough for the start. That's a ton of embeds. Okay, that was a mini organizational task I had to do. And now we can continue. Let me open up the Notion here. We also have for tasks, let me think, for tasks, we'll need a document for tasks as well. Arabic. Okay. Let's add that. Let's add this as well. And let me open up pin messages. So here are the tasks. For now, we can just start like this. And let me quickly create the project document as well. Let me copy paste the initial part from here. Truly open source NLLB checkpoints that can be freely used even for commercial purposes. Okay. Checkpoint. So open source checkpoints that can be freely used even for commercial purposes. Okay. Next up, let me link community, language champions, tasks. Let me just link a couple of these things. We need a rocket here. We really, really need a rocket. I want to see that rocket. Okay. Yes. Okay. So tasks. Let me open the server. Let me just open up any of these and just, I need to paste my link here. Okay. So join the server. Why am I stuck? How do I link up? Okay, let me just add a link, insert a link. If you want to engage with the rest of the community, daily streams are gonna be on my channel. Language champions. Let me share that document. Okay. Looking good. Looking good there as well. Community, language champions document. Is there anything else I'm missing here? So open source ticket up being referred to 7 billion and scope down the supported languages so that we supporting different language family groups. Okay. Okay. So now we have the pins. Identify common challenges for our projects and propose suggest solutions from different initiatives or coordinate collaborations. Let me just put this new document here so we can store everything, so I can organize myself as well. So here are our documents. Here is the main one. These ones, here's my local to-do list. And let's now go and play with filtering. This is the to-do for today. Sorry guys, a bit more organizational stuff now, but okay. It seems they got a notification as well. Let me open up my Notion. So I was very optimistic, and I started making separate documents for each of the streams, but it doesn't make any sense. So let's kind of skim quickly through these, and let's just create an actual document with let's just extract insights. I'm gonna call this one datasets licenses, because we went through and kind of labeled all of the licenses for all of the datasets. Awesome. We already have mine data. We already have some people reaching out, like Chris. Compute. I'm gonna put these to-dos up there. Oops, not this. We've done this. Let's see, what do we have here? Laser. We can just delete all to-dos. We didn't have to do this. Okay. Day 3. GPT Neo X. We went through this. We went through this. We can delete all of this. We don't really care about PIs because we already have the mine data. Let's maybe put this here. Although it won't be important. This is again something that should go to laser. And we can freely delete this. Why it's not working? We don't care about that to-do. It doesn't have to be brought to the top level to-dos. Wrap up that dataset section of the NLLB paper. We quickly mentioned that we decided to use FairSec as GPT Neo X doesn't really support encoders. This can maybe go to the main document. The reason we considered GPT Neo X was because many people from the community might be more familiar, comfortable with it. Okay. Dataset analysis. Training details. Okay, we need to extract this from here. Let's dump it here. Let's delete this file. Let's see day 7. So this is the latest one. Okay. Checkbox. Where is the checkbox in Google Doc? How does one create a checkbox here? To do item. Okay, here it is. Okay. Mind by text metadata. LNI folks replicated it here. I'm just gonna leave that as it is. Streaming schedule. I'm gonna keep these on my side for now. Data. wrap up the mapping, run the filtering pipeline, create a README, stopes, refactor, and push. We've done this. Whoops, not really that. We want to keep those to-dos. Okay, robustify filtering. Okay, there is a ton of tasks I left here. Let me bring all of this to the top level. Actually not, I'm gonna keep my to-dos here so that this document is kept nice and clean. Okay. Gonna push this to ape index. Only people with access can open with a link. Anyone with a link can be a commenter. Submitted an issue. Waiting for a reply there, okay. Improve toxicity lists, maybe, just maybe. I think we just first need to push through and start training and then start iterating. This is more of a detail to improve the performance rather than to get it working in the first place. Okay. Let me see how I can organize this. Did I have any other issues that I submitted and I didn't get a reply for? Short tutorial. One of them is open. So this one. And commits, repos, issues. Okay, that's completed. So there is a couple of open ones. I don't care about this one. Okay. That's it. Next steps today. So that was a bit of organizational over the last hour, focusing on organizing the community, sorting the documentation, my notes as well. Logistics, organize a datathon so that people can verify the quality of translations of their native languages. Okay, make sure people are aware of this. So there is one thing I have to fix here. People joining the server don't really see during the onboarding. Let's see what are the default channels. Okay, these are the default channels. These 5, 10 channels. Let me just see how we can set this so that people are aware of the Meta NLLB project before when they join. So this is very important. Otherwise, we'll be losing a lot of people here. No, we can actually just add a question here or add an answer. How can we modify this one? Ah. Okay. Should be good now. Let's just double check. This is still here. It is. 2 channels are invisible for some reason. 2 are missing. Welcome new members. That's fine. And NLP study group. Brian will be happy to see we have this. Study group. And maybe we can put the book there. And that's it. Save. We are done. Let me just double check this is saved. It is. Awesome. Here's a new person who is joining. That's awesome. Join the channel. Backend software engineer. Great. It's no matter what your language is, we definitely welcome people. Okay, let me just ask Raffle, can we somehow automatically assign people open NLLB roles when they comment here? Okay. Let's create a post that's gonna handle all of these 4 to-dos, and then we're gonna go back there. Should we train on reverse directions? Let's sort out this logistics to-dos, and then we can continue on with our regular streaming vibes, which is just going through code, making sure we can kick off the training run over the next couple of days. Okay, let me just write a bigger post. Yep. Okay, I already made an update about this. Let me just see, make sure people are aware of the NLLB channel. That's already the case. Make people champions of their own language if we have a linguistic. Okay, I think it's better to save this until we... Let me just edit maybe this post. I think this is good. This is already handling the logistics. Okay, guys. Let me quickly just go stretch my legs and we can continue. Let me just add a note here. And be right back. And then let's go and understand why the filtering was failing. And then we can start the data processing part, if that makes sense. Zvezdan, yeah, I mean, you can contribute. You'll be able to contribute maybe for Serbian and some similar languages that you probably speak, like Bosnian, Croatian, or whatnot. Although ideally we'd actually have the natives, because there are subtle differences with Croatian and Bosnian that I oftentimes omit J letter or something like that. Okay, guys, off to just stretch my legs and be right back in a couple minutes. I'm back, guys. Let's go. Let's do some coding. Stretching my leg. Stopes, filtering. Why is it not working? Okay. Let me delete these two. Move to trash. I think I have an idea of what we need to do. Let's reduce the number of directions. Let's split this in such a way that we have maybe like 20 directions per job or something, and then it might work. So how can we do that in a nice way? Let's analyze the filter pi here. So filter group config. Yeah, let's just create a for loop here. Let's just create a for loop so that we process 10 directions at a time. I think that might make sense. And probably we won't have any issues. So directions, let's do it like this. Let's go for I in range this, and then let's make steps. So let's start at 0. Let's end there. Let's go with a step of 10. And then grab let's make a all directions variable. And then we can modify directions here, config directions, exactly. I through I plus 10, and then pass that. Does that make sense? So we grab all of the directions, we grab a subset, then we go through the group names, and we can freely for now remove this to ease my debugging. Add back. Okay. So config directions has been modified. We grab train primary. We pass that in, and we pass in the config. Included corpora can always remain the same. I think this is not good. Is filter group going to be a blocking one or not? Is it going to be a blocking function? Can we... Yes, I think this is going to be a blocking job. So let's put a breakpoint there. And let's rerun this. Let me just see. We want the filtering config. Let's just see what the filtering config looks like. Filtering, filter out. That's all good now. Open up the filtering pi. And kick off the run. Okay. I0. We grab the first 10 directions. and we wait, what's going on? Oh, okay. We need that comma. Otherwise, it was literally just grabbing character by character. Silly bug. So group name, all good. And let's run the filter group. So now we'll have 10 processes. Let's see whether any of these fail. And each of them has additional sub-process. Interesting. Okay, seems... Okay, the first 10 worked. Awesome. First 10 directions all completed successfully. We didn't get any errors. Why are we printing this huge file? Because user warning, running with config. Okay, directions. This is just our YAML config, the example config. And then we ran 10 jobs. Let's now start again. Hi, Lilith. Or were you waving when I went to stretch my legs? I'm not sure. Looking good. Now we go and grab yet another 10 directions. But for some reason, this is set to... Okay, wait. What did happen here? Why is all directions empty? This is probably doing shallow copying or something. Let me just do a deep copy. Python deep copy. Copy deep copy. Okay. Let's import copy. Let's do copy deep copy of this, and then we can run. Okay, that was a nasty bug. Filter out. Let's again delete all of these. Or maybe just maybe we also need to change the output here. I think that might be reasonable. So under filter out, so we grab directions, that's fine, that's fine. Then we make the output directory, that's fine. Then we dump the config there. That's good. And then here, I think we need to change the output directory as well. So let's modify the output directory so that we are actually, yes, output directory, and then batch I through I plus whatever is the length of config directions. And then we need to obviously make directory. And that's what it's gonna look like. So we changed the format a bit. Okay, this should now handle the filtering. So batch size 10. Let me maybe specify batch size 10. Later we can potentially extract that into a config. So we grab only these directions and then we create a new output directory and we pass that one in there. Okay, no, this is actually going to be an error. Root output directory. And we are going to do what? Every time we're going to take the root and change the output directory here. And then we make it. And then at the end, we actually want to say root. Bothers me every time I see OS path instead of pathlib. I mean, with both you can do your job, right? I'm mostly used to using OS path, to be honest, rather than pathlib. But you might be right. Like, it might be easier to work with pathlib. I don't know. What are the main advantages in your opinion, Andy? What can you do in pathlib that you can't do in OS path? Or is it mostly just syntax? Like, it's nicer APIs or whatnot? Okay, this looks good. We grab directions. Okay, let's just run this. Taking too much time to analyze stuff. We grab 10 directions. We construct a new output directory. We create that directory here under. Okay, looking good. And then we run this job. And at the end, we have a breakpoint. Hit F5. Each of them will have executor logs, and each of them will have 10 directions that they support. The premise of this, again, is to avoid some of the issues we previously hit, because I think we had too many processes. Now this looks good. Okay, we're gonna hit the breakpoint. Let's exit. Let's start again. So again, directions, 10 new directions. I set to 10, looking good. Output, okay, it's a new directory. Underneath filter out. Awesome, awesome, awesome. Let's just kick it off. Let's see whether there are any issues in dispatch. I'll have to kind of babysit this for now, just to understand what's going on. Mostly syntax, a lot neater, and it has all the make directory stuff too. Okay, fair enough. I should probably invest to learn a bit more about pathlib. We've been using pathlib as well in this project. It's kind of mixed between OS path and which is something I'm familiar with, and pathlib. Okay, first 20 directions are done. How many directions do we have? In total, we have, whoops, 277. So that means 27 batches. We are batch 3. It might be the case that some of these have much more data, because obviously some directions that involved English might have a lot more data, and I'm not sure whether that will cause the issues or the fact that we were previously spawning 200, literally a ton of processes to process each of the directions, 277 to be exact, and now we're doing them in batch of 10 instead. So we are babysitting that. While we are babysitting, we can slowly, I think, start playing with data processing pipeline. Okay, this one is obviously a bit taking a bit longer. Let's see what languages are we dealing with. We're dealing with, interesting, Azerbaijani and Russian. This, I wouldn't expect this to take that much time. Whereas the previous ones were mostly Arabic languages, apparently. Okay, looking good. Again, this is just a modification so that people can run this locally. Whereas Meta folks were mostly running all of this on Slurm clusters. Let's read the Stopes description for how to process data, which is somewhere in Stopes. Okay, data, prepare data pipeline. Let's go here. So this pipeline takes in the filtered corpora text files, can be compressed. So that's the thing we're currently working on, right? That's the thing we're currently working on. Trains an SPM model. That's not what we're gonna do. We're gonna pass the pre-trained model. And then deduplicates shards, encodes, and binarizes them in the format required by FAIRSEC. An array of jobs is scheduled whenever possible, in particular for validate, retrieve data, dedupe sharding, and binarizing. The pipeline uses the caching feature of Stopes. After we run this, I'm gonna get an estimate. How much data are we currently dealing with after filtering? We need to understand the number of tokens we'll be passing to our model. And I think we can just kick off the training run. Okay, so we have a ton of different folds. Language direction, corpora config, language direction, corpus name, source target, metadata, and then optional stuff. Okay, processing, Boolean values for Moses processing, vocab, specify vocab params for source and target vocab, train jointly by default, deduplication, how to deduplicate, whether across folds, and how to use individual sentences, sharding, how to shard, total sentences per shard, and the minimum number of sentences for each language direction per shard, launcher, how to launch locally or submit it, which is just a Python wrapper around Slurm. Please override the default config options as required. So run the prepare data and set up the output directory. Fair enough. And then here's the breakdown. I already previously played with this repo myself before I started streaming, so I have some familiarity. Okay, we are done with our third batch. Let's continue on the fourth one. Again, just babysitting this a bit so that we see whether and when do we have issues. And also, if we hit an issue in a particular batch, it's easier to recompute that particular batch than trigger the whole job. Okay, validate, counts the number of lines for all parallel corpora and make sure they are the same for source and target, and stores train line counts statistics. Fair enough. Concatenates all corpora for each, runs Moses as per pre-processing config and saves them to the retrieve data directory. Okay. Build vocab, samples a corpus as per sampling config and trains an SPM. Okay guys, my battery just died. I'll resume in 2 minutes.